Hello and welcome back. In this video, we are going to look at how to perform fractional max pool in TensorFlow. Before we look at the code, let's look at the calculations manually. Let's say we have this tensor here, which has 6 rows and 3 columns. So what we can do in fractional max pooling is we can use a fraction to determine the number of rows and number of columns we can use to pool over. Uh, for example, rather than saying we want to pool over a grid of 2 by 2, we can specify a fraction. And the way this fraction is calculated is as follows. So the ratio or fraction is equal to number of rows divided by number of rows in the input divided by number of rows in the output. And in this case, what we know is the ratio and the number of rows in the input. So we can go ahead and calculate the number of rows in the output, which is going to be number of rows in the input divided by the ratio. And the number of rows here in the input, which is x, is equal to 6. And the ratio is, let's say we are using the ratio of 2.3 for rows, and this is for rows, and then we have the same thing here for height. And when we calculate this, I'm doing it on my calculator. So we have 6 divided by 2.3, that gives us 2.6. And what we need to do is floor this 2.6, and that gives us a value of 2. Likewise, we can calculate the same set of values using the ratio for the columns. And in this case, then what we would say is the ratio is equal to number of columns in the input divided by number of columns in the output. And so the number of columns that we would have in the output is going to be number of columns in the input divided by the ratio. And again here the ratio is 2.3, which is what we have specified here, and number of columns is 1, 2, and 3. So we have 3 columns. Now when we divide 3 by 2.3, this gives us 1.30. And when we floor this, we have 1.3 floor of that, we get a value of 1. So based on these two calculated values, we can then say that the output shape is going to be 1 comma, that's for the batch, then we have 2 comma 1, that's for the row, this for the columns, and then this is for the channels. 2 by 1. So essentially we are going to use a 2 by 1 grid to perform the max pooling operation on this. No, sorry, my mistake. Not 2 by 1 grid, but that's going to be the output. And based to get that output, what we need to do is another intermediate step, which is we need to find the row pooling sequence. So we need, let's use a different color. We need a row pooling sequence, and this is going to tell us how we want to sort of split this particular input tensor along the rows. So for rows, the indices that we have are as follows. We have this is 0, then 1, 2, 3, 4, 5, and so that's so if we want to include 5, we can give the index 6. We have 2 rows in the output, as we can see. So what we can do is we need to divide this particular set of rows into 2 parts. So we can divide this as like this. And so what we end up are this section up here, which can be represented by index rows from starting at index 0 going up to index 3. So uh, we go to 1, then 1 to 2, and then this is 3, but we do not include 3, so we stop at 2, and therefore we are going to use a value of 3 here because we need the row 2 included. If we had put 2, then we won't be able to include the number 2. So we put a 0, then 3, and then the next set is going to start at 3. It will go up to 6, but not 6. So 3, 4, 5, those will be the rows we would include. Next, what we need is the column pooling sequence. Column pooling sequence. And again, in this particular case, what we are looking for is just 1, and in here what we have is uh, because we just have one value for the column in the output, this is going to be just one block that we would have to use. Let me go ahead and reconnect this. Yeah, we would just need one block, and we start here at 0, then we have 1, 2, and then let's put an index 3 that's outside of this. Now to create a one block, essentially we are going to have to use this entire thing. So we start at 0 and we go up to 3. So it means that we include the rows 0, 1, and 2 in there. Right. So based on this, we can now start performing the max pooling operation. And for that, let's look at the very first block. The first block will start at 0 along the rows, go up to index 3. So we are talking about this first block right up to here, up to 3. So we cannot include 3. And columns we want to start at 0 and go up to 3 again. So we would go right up here. And the values that are inside of this particular red square, those are the values we need to use and find the maximum value from those values. And as we can see, the maximum value is 9 in this case, so we just put a 9. The next block that we are going to look at is going to be from index 3 to index 6 up to index 6. So we are essentially going to look at this part 3 up to 6, and for this again the columns that we need to look at are all the 3 columns starting at index 0 right up to index 3, and so these are the values we have. And from these values we need to find out the maximum value, and as you can see, the largest value in this bottom red square is 18, and so that is the output tensor that we have. uh, so the shape is 2 by 1, so rather than writing it like this, maybe the correct way to write this would be uh, something like this. So we have 2 rows and 1 column, and that's the output tensor. Now what we can do is try and run the code and see how, if the output matches with what we have calculated manually. So that's that, and let me clear this part of the screen. And here for implementing the max pool, as you can see, the code is pretty straightforward. We type tf.nn.fractional underscore max underscore pool, and then what we have, what we need to do is input a value, the input value, that's the tensor x that we have above. Then we need to specify the pooling ratio, and the pooling ratio, as you can see, starts with floating 1, so we have 1.0, ends with 1.0, that is needed. And then down in the middle, then we have the values of fraction for the row and fraction for the columns, and these values have to be greater than 1 as is mentioned here. Rest of the values we leave it as default, and down here then we can verify our results. So the output shape is 2 by 1 by 2 by 1 by 1, and that's exactly what we have here. So this is good. Then the shape of and then the output values are 9 and 18, and those are the values we did get in the calculations. Finally, the row pooling sequence is 0, 3, 6, and that's the sequence we have here, 0, 3, and 6. And the column pooling sequence is 0 and 3, and that's exactly the sequence we have here, which is 0, 3. So this is how we can perform fractional max pooling in TensorFlow. Let's quickly try and use another ratio just to see that our logic holds. And what I'll do is, instead of using 2.3, let's use a different value this time. Let's say 1.1. Let's type the 1.1, and then the second value, let's use this value as, let's say, 2.7. Maybe those are the that let's say that is the ratio we need to use. And if we are again going to use the same tensor, what I'll do is I'll clear off some of the values up here so that we can recalculate the values, and like so. Remove those, again remove these, and let's try one more time. So the first thing we need to do is specify the index. So let's say 0, 1, 2, 3, 4, 5. We have 6. And again for the columns, we have 0, 1, 2, and we have the 3 here. All right. So with this, then what we can do next is calculate the uh, sequence, pool row and column pooling sequence. So for the rows, the number of rows we have again is 6. So we put a 6 here. Then the ratio that we are using for the rows this time, it is 1.1. So I'm going to divide the 6 by 1.1, and let's see what values we get. So 6 divided by 1.1, that gives us a value of hold on, 6 divided by 1.1, that gives us a value of 5.45. And if we floor this, we simply get a value of 5. Likewise, if we look at the columns, we can see that there are 3 columns as before, and then the ratio that we are using is 2.7. If we divide 3 divided by 2.7 and run this, we get a value of 1.11. And that if we floor that, we get a value of 1. So now with this particular setup, let's try and see what how we split this particular input tensor. And so the first case, all right, before we do that, we need the input sequence. And so for that, we need so the shape is going to be 5 by 1 right here. So uh, what we need is, so number of rows in the output is going to 5, columns is going to be 1, and so what we need is uh, to divide this particular rows into 5 sets. So let's see how we could do that. If we divide it here, we have 1, 2, 3, 4, then divide it here. This becomes, we have 1, 2, 3, 4, 5, and that becomes 6. So how about we just drop this and leave that there. So that way we have the 5 values. And so we could say that the input sequence, oh sorry, the row pooling sequence would start at 0. Then we have the value of 2, 3, 4. So we have 0 to 2, 2 to 3, 4. And then from 4, we have 1, 2, oh, sorry, I missed 1 there. Put a 1. We have 0 to 1, 1 to 2, 2 to 3, 3 to 4, and 4 to this is 1, 2, 3, 4, 5. So this one we need to put 6 because we will have to include the 5 there. And likewise for the columns, the sequence that we would have to use is start at 0 and then go all the way up to 3 because we just have one there, so we do not have any splits within this. Now the values for max pooling would be based on these set of values. We start at 0 and then we go up to the row 1, so we stay in the first row and then go all the way across. So what this is telling us is take all the rows that start at index 0 and go up to index 1. That is essentially saying that just take the row with index 0. And for columns, we start at the column with index 0 and go all the way up to the column at index up to the column at index 3, which is to say that take the columns with index 0, 1 and 2, exclude 3. And based on the values that we have here, we can write the maximum value. In this case, it's going to be the value of 3. So let's put a 3. And likewise, then we would have the other value. The next set would start at 1 index for the row and go up to the index 2, which is to say that just use the row index 1 and then take all the columns as before. So the maximum value in this case then is going to be 6, and so we put a 6 there. If we keep going through this, the next set of values we have is this one, and so the maximum value in this 7, 8, 9 is just 9. And then we keep going to the next round, and in here we have this particular set. We start at index 3, go up to the index 4, and we have columns that start at index 0, go up to the index 3. The maximum value in this case is going to be just 12. And finally, the value that we have, we start at index 4 and go all the way up to the index 6, so include 5 and all the columns. And so the value that we would get in this case, the maximum value here is 18. And so that is our output tensor. Let's see if we get the same value if we perform the calculation using this particular code that we already have written. So let's run this. And so 2.7, that's what we used, and run the code down here, and we could go ahead and clear this particular part. That okay. So the output that we see is looks similar to what we have. The output shape is 1511, and that's what we have here, 1511. Then the values in the output tensor are 3, 9, 12, 15, 18. So we do not have the same values. We have 3, 9, 12, 15 and 18. And I think the reason for that is we missed we used a different set of pooling sequence. So the pooling sequence here is 0, 1, 3, 4, 5, 6. We have 0, 1, 3. So, so the first one, the smallest one is in the beginning, then 1, 3. So that's the larger one here. Then we have 4, and then the 5 and 6. Why don't we do this? What if we try running this again and see if what output we get? So, so this time we got the values that match with what we have. As you can see, we have 3, 6, 9, 12, 18, and here we have 0, 1, 2, 3, 4, 5. Sorry, 0, 1, 2, 3, 4, 6. 0, 1, 2, 3, 4, 6, and so 0, 3. So that's how we can calculate the fractional max pooling in TensorFlow. And as you saw, looks like the row sequence and pooling sequence is and change based on how you run it. So that could be random, and probably lucky to see that the values that we calculated were the values chosen in the previous run. If you have any questions, comments, or suggestions, please do let me know in the comment section below. I hope to see you all in the next video. Thank you.